I'm going to do a quick little video on the chain rule with trig functions. Alright, last time we went over the derivative, the function with their derivatives. I'm not going to spend a lot of time. You can pause the video if you want and rewrite those notes. But what I do want to get into this time is the fact when we have something with a power. So some sine function, cosine, some trig function has been raised to a power. Now we see it oftentimes written like this, where it's the sine squared of u. We see it in the identities, cosine squared of u, or sine squared of theta plus cosine squared of theta equals 1. We see these squared or cubes a lot when we run into trig functions, especially in the identities. So what we need to do is, how do we take the derivative of that? Well, we can always rewrite sine squared of u equals the sine u squared. So we bring that out, the power to the outside, and now it looks like a normal chain rule type problem. Well, when we have it in this function, written this way, now we can bring the n down, and we multiply the n here, we reduce the power, and that means we've got sine of u here. We keep that the same, right? This piece is the same as the original function, which we'll see. Then we take the derivative, d dx, of the sine of the inside piece. We multiply that together. Then finally, we take the derivative of the u. All right, so 3 steps here we have to make sure we look at when we're multiplying these or finding the derivative. All right, you can see behind me we've got the derivative of sine cubed 4x. I'm going to challenge you to pause the video, see if based upon that information you can put it together, and we'll see how you do. All right, here we go. Let's look at it. The derivative of sine cubed of 4x on the inside. So we know that we have to take the derivative of this inside piece. What does that 4 do? Well, if you remember that the 4 on the inside, that has to do with the period, the 2 pi over b. And so that tells us how many more revolutions or rotations we might get within that sine function. All right, so we first want to rewrite it as the sine of 4x cubed. Put that in green. That's the outside piece. Then we have an inside. Then we have another small inside piece. So we bring the 3 down. Here's the big 3. We reduce the power. The inside stays the same, sine of 4x. Okay? We multiply that by the derivative of the inside. Well, the derivative of sine is cosine. Okay? Then we take that 4, don't worry about that 3, that's just for the next problem. We take that 4x on the inside and we take the derivative of that, which is 4. So now we want to combine everything together. The answer is 4 times 3, which is 12. Times sine 4x squared. Hopefully you can see that squared right there. We've got that 2 from there. Times cosine of 4x. All right. Example number 2. Here we go. We have the derivative of the square root of cosine of 3x. Well, now we want to rewrite it as cosine of 3x to the 1/2 power. All right. Now, when we do that, we bring down the 1/2. We have cosine of 3x still on the inside. That doesn't change. But now when we reduce the power, 1/2 minus 1 is negative 1/2. So we have times the sine of 3x, right? The derivative of cosine of 3x is negative sine of 3x, and then we take the derivative of 3. All right, so what that brings us to is 3 times negative is negative 3 sine of 3x. Well, look, here's our 2. That came from there. But wait, what are we missing right here? This doesn't just go down by itself. It's to the negative 1/2 power. So hopefully you caught that. And look, we can take the square root of that part. Or you can leave it as cosine 3x to the 1/2 power. Now it would be positive because it's already in the denominator. So your final answer here, negative 3 sine 3x divided by 2 times the square root of cosine of 3x. All right? Hope you enjoyed that. Thanks a lot. See you soon.